All right, let's jump right in. You've probably seen shapes spinning around in animations or video games, right? But have you ever stopped to think about the actual math behind it? Well, today we're going to tackle a classic geometry problem, rotating a shape. Now, it might sound simple, but there's a really neat trick to it, especially when the rotation isn't happening right at the center of everything.
So here's the challenge we're looking at. We've got this green rectangle, and our job is to rotate it 90 degrees clockwise. Simple enough, right? But here's the catch. We're not spinning it around its own center, or even around the graph's origin. Nope. We have to rotate it around this very specific point, right here, 1, 1.
And you know what? That's where things get interesting. See, rotating something around the origin, that 0, 0 point right in the middle, that's pretty straightforward. There are simple rules for that. But what do you do with a random point, like 1, 1? How in the world do you handle that? Well, that's the exact question we're going to answer.
And the solution, you'll see, is all about a really clever shift in perspective. So this really gets to the heart of the matter, doesn't it? If you're rotating at the origin, it's easy peasy. There's a simple, predictable rule for it. But rotating around some other point, like R1, 1, that just feels tricky. You'd think you'd need some crazy new complicated formula, right? Well, the good news is you absolutely don't. And this right here, this is our secret weapon. This is the big idea for this whole thing. We're going to take this hard problem, and we're just going to turn it into an easy one first. Honestly, it's an amazing trick for solving problems, not just in math, but in pretty much anything. So how do we do it? With this simple 3-step plan. First, we shift the whole setup so our tricky rotation point at 1, 1 moves to the easy-to-use origin at 0, 0. Second, we do the turn. We just use that simple rotation rule now that we're at the origin. And finally, step 3, we return everything back to where it came from. Shift, turn, return. It's that simple. Let's walk through it.
All right, let's dive into that first step. It's all about the shift.
Now, the official math term for this shift is a translation. But all that really means is that we're sliding the entire picture, both the rectangle and our rotation point, without, stretching it, shrinking it, or twisting it at all. So how do we actually do this shift? Well, to get our center point from 1, 1 to the origin at 0, 0, it's pretty simple. We just need to subtract 1 from its x value and 1 from its y value. But here's the key. Whatever we do to the center, we have to do to every single corner of our rectangle. That keeps everything in the right place relative to each other. So we're going to take each corner's coordinates and just subtract 1, 1 from them to get our new shifted points. Okay, the shift is done. Now our whole problem is centered at the origin, which means we're ready for the easy part. Let's get to step 2, the simple turn. And this is the whole reason we did that shift. The rule for a 90-degree clockwise rotation around the origin is awesome. It's so straightforward. Any point, x, y, just turns into y, negative x. So what does that mean? You swap the x and the y, and then you just flip the sign of the original x value. That's it.
Okay, let's put that rule into action on our shifted points. Let's take the first one, negative 7, 4. Here, x is negative 7 and y is 4. The rule is y negative x. So we take our y, which is 4, and that becomes our new x. Then we take our x, which is negative 7, and we flip its sign. So negative 7 becomes a positive 7. That's our new y. And boom, our new point is 4, 7. We just do that exact same thing for the other 3 points. See? Super easy once everything's at the origin.
We are so close. Our rectangle is perfectly rotated now, but it's just in the wrong spot. It's time for our final step, the journey home.
And this part is basically just undoing what we did in step 1. Remember how we subtracted 1, 1 to move everything? Well, to get back to where we started, we just do the opposite. We add 1, 1 back to all of our new rotated coordinates.
And here's that last little bit of math. We take a rotated point, like 4, 7, we add 1, 1 back to it, and we get our final coordinate, 5, 8. We just do that for all 4 corners, and just like that, we have the final correct coordinates for our rotated rectangle.
All right, the moment of truth. Let's see what our final answer actually looks like.
And there you have it. On the left is where we started, and on the right is our final rotated shape. You can see it perfectly. It swung 90 degrees clockwise, pivoting right around that point 1, 1. It landed exactly where our math told us it would. A perfect rotation. So when all is said and done, what's the big takeaway here? It's this beautiful, super simple 3-step method. Anytime you have a complex rotation, just remember this. First, you shift the problem to make it easy. Then you turn the shape using that simple origin rule. And finally, you return it back to where it belongs. Shift, turn, return. It's a game plan that'll work for any rotation around any point. And that just about wraps it up. But I want to leave you with one last thought. This shift, turn, return trick, it's more than just a neat bit of geometry. It's really a whole strategy for problem solving. So here's a question for you. Now that you know this trick, where else, maybe in another math class, or maybe even somewhere totally outside of math, in your everyday life, could you use this idea? You know, the idea of making a problem simpler first, just so you can solve it? It's something to think about.